All right, let's get this math review fired up. Just a couple quick announcements before we get started. I've actually already uploaded the quiz for math on Blackboard, so this review is going to follow that. I figure I'm not covering really anything new, just reviewing stuff that you've had in previous classes, so no reason to go ahead and or not to go ahead on that. What I've done for this review is I've collected some of the questions that I've done in the past and combined them into a single review, which covers the topics on the exam. The topics on the exam for math updated this July, so they've at least for the civil engineers they've combined the math and the statistics all into to one section, and the probability aspect of it is significantly reduced. So this set of questions is reflective of the at least in my opinion the new structure of the exam. There's going to be a lot more problems that have been done in previous reviews that we've done this semester, but also the problems are a little bit shorter. I mean, that's kind of the nature of the math section of the exam. And it's going to go kind of rapid fire where it's just me recording the video. I'm going to go through the problems a lot faster than I probably would while we're in class. So with that, I'm going to go ahead and get this fired up. Let me turn the pen on, turn on red. Let's go ahead and get started. So problem one, we're starting off in analytic geometry land. What is the length of a line segment with a slope of 4/3 measured from the y-axis to a point of 6 comma 4? So first thing we ought to do is determine the equation of the line. So we know that the slope of this line is 4/3. And from the statement in the question, we know that it passes through the point 6 comma 4. So what we can do is determine the equation of the line using point slope formula. So y minus 4 equals 4/3 x minus 6. And that's going to be y minus 4 equals 4/3 x minus, and so that's going to be 8, or y equals 4/3 x minus 4. So that's the equation of the line. And we're measuring the length of that segment from the point 6 comma 4 to the y-axis. Okay, and so maybe we ought to just graph this line. This is the x-axis, this is the y-axis. I mean, if I look at this this line, what do I know about it? Well, I know it crosses the y-axis at 0 comma minus 4, because minus 4 is the y-intercept right here, and so the line's probably going to look something like that. And this point right here, I don't know what that point is, sorry, but I do know that it crosses, somewhere up here. Maybe I should draw it more like that. And this point right here is going to be 6 comma 4. So basically what I'm getting at is I've got my 2 points in order to determine the length of the line segment, because the original statement in the problem said I needed to determine the length of the line segment with a line that has a slope of 4/3 measured from the y-axis to this point. So if I erase all this because I want to use this room here, I now have my 2 points. My points are 6 comma 4 and 0 comma minus 4, because that's the y-intercept. So the distance, or the length of that segment, is the square root of the change in x squared plus the change in y squared, which is the square root of, so we'll say 0 minus 6 squared and negative 4 minus 4 squared. So the square root of 36 plus negative 4 plus negative 4 is negative 8. Negative 8 squared is 64. So the square root of 100, which is 10. All right. So a little bit involved, but hopefully you should see that's pretty straightforward. Okay, moving on. Next question. And what I'll do is I'll try and wait a little bit. So as you're watching the video, if you want to pause and then give the problems a college try before I go through the solution. What's the general form of the equation for a line whose x-intercept is 4 and y-intercept is -6? So ultimately what we need to do is use the equation of the line, just get it in the form that you see here. So even if you don't remember the equation of a line, you can just use some algebra to get it in this fashion. So instead of using point-slope formula, we've got 2 points. Now, what are the 2 points? Oh, sorry, I didn't mean to do that. What we know is the x-intercept is 4, so that's 4, 0. And we know the y-intercept, 0, -6. So we can determine the slope, which is the change in y over the change in x, which is, so -6 minus 0, 0 minus 4. So that's, what is that, -6 over -4, so +3 over 2. So what that means is, we know our y-intercept. Our y-intercept is -6. So y is 3/2 x minus 6. And so this is the, slope-intercept form of the line. We just need to get it into general form, into standard form, the ax plus by plus c equals 0. So what I'm going to do is I'm going to take this equation right here. I'm going to multiply both sides by 2. And then, if I'm multiplying both sides by 2, that's 12. And then get everything all over to one side. And so the easiest way to do that is just subtract 2y from both sides. And there you go. Pretty straightforward. Okay, moving on. Problem 3. So we're going to look at problem 3. This is a logarithms problem. Now, to be clear, you could probably plug this into your calculator, but the purpose of this problem is to kind of review those properties of logarithms. Probably been a while since you've looked at some of these. So let's see what we can do here. So first off, it might been a while since you've done this, but if you remember from logarithms, if you have the logarithm of a minus the logarithm of b, that equals the logarithm of a divided by b. So we can take this and represent it as 12 over 2. Or maybe I'll just simplify that even further and just say 6. Okay. And likewise, if you have the log of a plus the log of b, that's the same as the log of ab, multiplying them. So that's the base 3 log of 3/2 of 6, which is 9. And the thing to remember is, what is a logarithm? If I have the base 3 log of 9, what is the base 3 log of 9? I'm asking, if the base 3 log of 9 is, let's say, x, what this means is I'm asking, if I take 3 and raise it to some power x, I get 9. So what is x? It's 2. There's also a possibility that, again, your Casio or something like that, you could just plug this in and get an answer. But again, this is trying to exercise those muscles, of those algebra muscles with your logarithm properties. Okay, moving on. So for some angle theta, we know that the cosecant of that angle is -8/5. So what is the cosine of 2 theta? Well, first off, if I know the cosecant, which, by the way, if you hear toddler in the background, that would be my daughter playing. So if the cosecant of that angle is -8/5, if you remember, the cosecant is just the reciprocal of the sine. So we know that the sine of that angle is -5/8. And so the question, this then becomes a trig identities problem. You know, I have the sine of theta, I have the cosine of 2 theta. What are the what's a relationship that I can use to relate those two? And that's where your manual comes into play. You can go into the went to the next problem. If I actually don't want to end the show because I don't want to leave the calculations here. But if you go into the manual, what you'll find is that the cosine of 2 times an angle is 1 minus 2 sine squared of that angle. It's probably been a while since you've looked at these, but again, they're all listed in the manual, all of your trig identities and whatnot, so it's worth a look to make sure you know where those are. So 1 minus 2, and then it's a quantity squared. That quantity is -5/8. So I use brackets there. I probably don't need to do that. So 1 minus 2, and so if I square a number, that's always going to be positive, and so that's what, 25/64. Multiplied by 2, that's 1 minus 25/32. So that's 32/32 minus 25/32, or 7/32. Again, just flexing those trig muscles a bit. Similarly, here's our next problem. This is looking at trig identities to try and simplify things. I've always found that whenever you've got to deal in trig identities, when possible, get it into sine and cosine. And if you get it into sine and cosine, chances are a lot of the simplification can go, it goes a lot smoother. So, for example, the cosecant, that's 1 over the sine. This is cosine third, or cosine cubed. And then maybe I ought to use brackets so my format's nice. And then this tangent, that's sine over the cosine. And so now I've got something that's a little easier to deal with. The sines cancel. And then I've got cosine cubed over cosine, so that's cosine squared. And one of the most fundamental trig identities is that the sine squared plus the cosine squared is always 1. So if I have the cosine squared, that is 1 minus sine squared. I probably ought to fix the formatting on that because that's supposed to be an exponent. I'll fix that for the upload, or for the PDF upload. Okay, moving on. All right. This one is not terribly difficult, although it might seem difficult. What is the value of x that will satisfy the following equation? Okay, first off, from an FE exam perspective, look, here's an equation. What's the problem asking? What's the value of x that will satisfy the following equation? The very first thing that you could do is literally just start plugging in 45 degrees, plugging in 90 degrees, plugging in 180 degrees, plugging in 270 degrees. Just plug in numbers. And whenever you get an answer that's 0, just go with that choice. So you don't have to be a mathematical purist to get the right answer. Remember, all you got to worry about on the FE exam is you have like an electronic bubble sheet. You know, this is question 6, and there's an A, a B, a C, and a D. And as long as you put the bubble in the right square, that's all that matters. So, you know, always think about in that regards. Now, what I'm going to do is look at this, though, just to give you kind of a problem-solving strategy, because there is some mathematical insight you can look into this. If I look at this equation, it kind of looks a lot like a quadratic. Like if I let, I don't know, a equal the sine of x, like if I did that, then this would be a squared plus 4a plus 3 equals 0. Now, I don't know about you, but that looks like a quadratic expression. That looks like something I can solve. I can factor that sucker. I can get a plus 1, a plus 3, right? Because the 3 is a prime number, so that's 1 and 3. They both have to be positive, and if they're both positive, I get that coefficient of 4. So that's a nice simple FOIL. And that'll yield that a is minus 1 or a is minus 3. Okay, and that's easy. Now let's go back to this part right here. That means that the sine of x has to be minus 1 or the sine of x is minus 3. And then you think to yourself, okay, what's the answer? Well, first off, if you could just say, x is the arcsine or the sine of minus 1. And you can just plug that into your calculator. And you will, I'll go ahead and tell you, you'll get 270 degrees. But what happens is about this one, if you plug in x is the arcsine of minus 3, chances are your calculator will spit out an error. Why is it spitting out an error right here? Well, I'll show you why. First off, let me go ahead and just box the answer. And let me leave that here. Okay. If I graph the sine function, what does it look like? Well, looks something like this. Actually, let me shorten that up a bit because I want to use that space here. Okay, this is pi, this is 2 pi, this is 3 pi over 2, etc. Now, this spot right here, that's plus 1, and then this spot right here is minus 1. Why are you going to get an error for this part right here? Because look at your y-axis. Your sine function is always contained between plus and minus 1 right here. You can't have a sine of an angle equal negative 3. Sine functions are always bound between plus or minus 1. So this first root right here doesn't make any sense. It won't work. And the only place that the sine of x is minus 1 is right here. And so that x would be 3 pi over 2, which in degrees is 270 degrees. So again, a couple different ways of looking at this, but again, you get the same answer. Okay, moving on. Problem 7. If the rectangular coordinates of a point are negative 3, negative 5.2, what are its polar coordinates? Okay, this is one of those problems where you can eliminate choices pretty easily. And this is also one of those problems where you could probably get the right answer without really doing any calculations. First off, polar coordinates. One of the things you should remember about polar coordinates, r, comma, theta, is r is the radius. R always has to be positive. That answer doesn't make any sense. Okay, so get rid of that one. And so the rest of them are answers that make sense. And notice how they all have the same radius. Now, does that value check out? Well, of course it checks out. If you do negative 3 squared plus negative 5.2 squared, you're going to get 6. Maybe because of calculation it rounds off a bit, but that's going to work out. The question then becomes, what's the value here? Well, let's see if we can just do some plotting here. So x, y. So if I were to plot this point in just xy coordinates, 1, 2, 3, 1, 2, 3, 4, 5. It's going to be like this. And so kind of drawing that scale, my angle is going to be that, or it's going to be, going this way. This would be plus theta. This would be minus theta going this way. So right off the bat, I know that this isn't the answer. It can't be positive because positive would be going this direction, and the line's obviously going the opposite way, so it's negative. The big kicker is whether or not it's 120 degrees and 150 or 150. Well, think about this from a scale perspective. Like if this was 150 degrees, it'd probably kind of look like that. Like that to me looks more like a 150 degree angle than this one here. That looks an awful lot like a 120 degree angle. But you don't have to take my horrible artistic skills at face value. Just recognize that, again, this dimension here, this is 5.2. This dimension here, that dimension there is 3. And ultimately, if we're trying to find that angle right there, we know it's going to be 90 degrees plus whatever that is. Maybe I shouldn't use the term theta. Maybe I should use alpha or something. Well, the tangent of alpha is 3 over 5.2. So alpha is the inverse tangent of 3 over 5.2. And when it's all said and done, you're going to get an alpha value of 30 degrees or theta of 120. So again, B is your answer. Again, just a review of your polar coordinates. All right, some more analytic geometry. The equation of a circle. Determine the coordinates of the center of the circle defined by the following equation that you see right here. Okay, this involves completing the square. First off, the equation of a circle. X minus h squared plus y minus k squared is r squared. This is the equation of a circle. Okay, so what we need to do is we need to get this equation in that format. And so how do we do that? Well, it involves completing the square. So how am I going to do that? I'm going to rewrite this as follows. And then what I'm going to do is I'm going to rewrite this with a negative 25. In other words, I'm going to take that 25 and bring it over to this side. Now you're going to see here in a second how that was kind of a wasted step, but if it's been a while since you've completed the square, this is probably a good idea. Okay, how do I complete the square? Well, let's take a look at the x terms. I take the negative 8, and it's a really simple trick. Take the negative 8, divide it by 2. Negative 8 divided by 2 is negative 4. Take negative 4 and square it, and I get positive 16. That is a very special number because if I take this and factor it, I get x minus 4 times x minus 4. Or x minus 4 quantity squared. So it gets it in that term that you see here in the box. That's what I'm trying to get it. I'm trying to get it in that term. But here's the thing. If I add 16 on one side of the equation, I have to add 16 to the other. Okay, same thing over here. What about the y squared minus 10y? We'll take the minus 10 divided by 2, minus 5, square that, 25, plus 25. Add 25 to both sides of the equation. Now you can see why the 25, that was kind of a wasted step because those are going to cancel. Plus y minus 5 squared equals 16. So therefore, x minus 4 squared plus y minus 5 squared is 4 squared. I propose that this is a circle with a radius of 4 and a center located at 4, 5. Pretty straightforward. Okay, moving on. Let's delve into calculus land. What is the slope of the curve when it crosses the positive part of the x-axis? Okay, so there's a couple things going on here. First thing that's going on here is when it crosses the positive part of the x-axis. Let's figure that part out first. Whenever something crosses the x-axis, it means when y equals 0. So when does this thing cross the y or the x-axis? Well, it's when y equals 0. 0 equals 10 minus, or 10, sorry, 10x squared minus 3x minus 1 means x is positive 3 plus or minus the square root of minus 3 squared minus 4, 10 minus 1 all over 2 times, sorry, 10. Quadratic formula, pretty easy. So 3 plus or minus, and so what do we have here? 3 squared is 9, 49, so the square root of 49, that's 7 over 20. And so that's going to be 3, so let's see, x is 3 plus 7, which is 10 over 20, a half, or 3 minus 7, which is negative 4 over 20, that's a fifth. So hopefully that didn't go too fast. Okay, so that's part of the answer. When it crosses the positive part of the x-axis, we're only going to be considered with that because this term crosses the negative part of the x-axis. Okay, now that answers that part of the question. What about this part of the question? What is the slope of the curve? Well, how do you find the slope of the curve? You take the derivative. So what is the derivative of 10x squared minus, so maybe I'll just go ahead and do it. 10x squared minus 3x minus 1. And so that equals the derivative of 10 times x squared 2x, that's 20x, minus 3. And so how do I find the slope when it crosses the positive part of the x-axis? Just plug in x equals a half. So 20 times a half minus 3 is 7. Not too bad. I wanted to try and tie up the algebra by doing a quadratic formula problem, but I also wanted to start to integrate, no pun intended there, I wanted to start to integrate some calculus into our review. Okay. This is a much more traditional calculus problem. What is the maximum value of the function on the interval x is less than 0? Okay, so this is a perfect example to break out your first and second derivatives. So your first derivative, let's do the first derivative. So I think we can do that one pretty quickly. 2 times x cubed 3x squared, so was that 6x squared? Plus the derivative of that is 24x minus 30. And then the second derivative is, that's going to be 12x plus 24. Okay. So, what do we need to do? We need to define a maximum value. So the first thing you have to do is you have to find an extrema. And how do you find an extrema? Set f prime equal to 0. Solve for x. Okay. So what do we got here? So 6x squared plus 24x minus 30 is 0. So I can divide the whole thing by 6. X squared plus, divide that by 6 is 4x minus 5 is 0. I think I can factor that. All right, so 5 and 1. And then if I make that positive and that negative, that works out. And so that yields x is 1 or minus 5. Now let's go back to the question. What is the maximum value of the function on the interval x is less than 0? So less than 0 means that I only consider that value. And so if I plug that value in, so if I say f of 5, what do I get when I plug in f of 5? I get 2 times minus 5 cubed plus 12 times minus 5 squared minus 30 times minus 5 plus 10. And if I plug that in, I'm going to get 210. So that's just, taking the derivative, setting it equal to 0, solving for x, taking that value of x, plugging it into the original function. Now that doesn't necessarily mean that 210 is the answer, because I know that there's a 210 choice right there. How do I know that that's the answer? Well, go back to the question. What is the maximum value? How do I know whether this is a maximum? Well, let's plug it into the second derivative. The second, what did I do there? I don't know what happened there. I think that was my zoom function here. Let's take the second derivative and plug in, sorry, that's minus 5. Let's plug in minus 5. So 12 times minus 5 plus 24. And if you plug that in, you should get minus 36. Now, what does that tell you? The second derivative tells you the concavity of the function. And at that particular point, a negative concavity means it opens downward. So what does that mean? That means this is a maximum, and that actually is our answer. If that wasn't the case, we'd probably have to plug in 0 and see what we would get to the original function. But if you plug in 0, none of those choices are in the A, B, C, D, because the answer would be 10. So just another little bit on some test-taking skills. Moving on. Some more on calculus. Now, limits. What is the value of the following limit? The limit as x approaches 0 of the sine of 5x over x. Now, if I plug in 0, what do I get? I get the limit as x approaches 0 of the sine of 0, which is 0 over 0. That's an indeterminate form. And if you remember from calculus, we have a little trick that we can use. L'Hopital's rule. And L'Hopital's rule states that what I do for that limit is I've got the fraction. Let me write that a little better. And what I do is I take the derivative of the top and take the derivative of the bottom. And that this limit will equal that limit. And so let's evaluate that, that derivative. So what do we got? The bottom's easy. The derivative of x is 1. What about the top? Well, we're going to have to do the chain rule here because we got the derivative of the outside, so it's the sine of a pile of junk, right? So what is the derivative of that? Well, it's the cosine times the derivative of that pile of junk. So the cosine of 5x times 5, because that's the derivative of the inside. And now I can plug in 0. So now we have that this equals 5 times the cosine of 0, 5 times 0. And the cosine of 0 is 1, so that is 5. We are rocking and rolling. Hopefully that was straightforward. Let's move on. A little bit more calculus. Okay. What is the result of the following indefinite integral? This is probably going to be one of the problems on this review that I actually don't do any work at all. And the reason why is this is another one of those problems where reviewing your choices matter. If you look at all of these choices have polynomial expressions except for one. That one. That little natural logarithm. Why does that draw my eye? Well, it draws my eye because of that. If you remember, the integral of dx over x is the natural logarithm of x. Of course, plus c. Don't forget that. So, without really even doing any math, that's your answer. Now, you can follow it along and say, okay, that's going to be 15 times x to the 5th over 5. That's going to be x to the 4th over 4. Natural log of x plus 7x plus c. You can evaluate it, and you'll see you'll get the same answer. But again, always view your choices. Okay. What is the result of the following indefinite integral? I think this is probably like one of the types of problems that students don't really like on the FE because it involves, oh God, I got to remember all those trig rules and substitutions and all that stuff. But it's not so bad, especially when you see a lot of sines and cosines. Usually what I like to do is I look at this and I see, okay, I've got a cosine and a sine, but there's a lot more going on with the cosine. So if I let u be the cosine of x, then du dx is sine of x. That's just taking the derivative. So du is the sine of x dx. Oh, wait, I forgot my negative. The derivative of the cosine is the minus sign. So this is u squared. This is minus du, right? Because the sign flips. So this is the integral of negative u squared du, which is negative 1/3 u cubed plus c. And u was cosine. Pretty straightforward. Pretty straightforward. Don't let these problems scare you. They're not as bad as you'd think. Okay. What is the total area of the region bounded by the x-axis and the curve y equals sine of x between this interval? I need a picture. First thing I'm going to do. Plot it. Excuse me. This is pi over 2, 3 pi over 2, 2 pi. What is the total area of the region? Well, I'm talking about that region there. I'm talking about that region there. Whenever you have integrals that sort of go on different sides of the x-axis and you're trying to determine that total region, remember that area is the integral of pi over 2 to pi of the sine of x. And this integral is, and maybe I'll put an absolute value on there to make sure that we handle any signs. Is whenever you're trying to determine total area, split it up into separate integrals, because sometimes what can happen, especially with these trig functions, is your areas will cancel each other out, like this area and that area will cancel each other out, and then the answer will seem smaller than it really is. So the area of this region is 1 and the area of this region is 2. So your actual answer is 3. But if you just evaluate from pi over 2 to 2 pi, if you plug that into your Casio, you'll actually get an answer of 1. So it's something to be wary of. This one's a little tricky, admittedly, but it's just trying to get you to think. And again, I didn't evaluate these integrals by hand because you can just plug this into your Casio and it'll give you the answer. And the Casio is something you can use on the exam. All right. Now, let's talk about this problem. I see this differential equation, and I'm sure some of you are like, okay, I'm just guessing C and moving on. I want to try and convince you to actually give the differential equations a shot. And I'm actually going to end the show here because I'm going to keep my annotations. I'm going to go to the FE reference handbook because I want to pull this up. I think this is important. So here's the FE reference handbook. Let me go to the math section. So here's the math section. We've got discrete math, which you aren't going to really have to worry about. Some basic geometry, logarithms, algebra, trig. Here's your trig identities I was talking about earlier. Areas and volumes. Keep going. Curvature. Derivatives. Okay, differential equations. Okay, let's scroll through this a bit. Now, let me go back to the problem. This is a second order differential equation with constant coefficients. And it's second order because the highest derivative is a second derivative. Look at this. Second order linear homogeneous differential equation with constant coefficients. That is exactly the problem that we're dealing with. And it literally tells you what the answer is. And if you just read it, you will get the answer. I'm going to go back to the slides and walk through this problem. It's really worthwhile to take this and give it an honest try. A lot of the differential equations that you get on the exam, you'd be thoroughly surprised how easy they are because a lot of times they follow just what's right here in the manual. Let me go back to the slides here. What is the general solution to this differential equation? First thing I'm going to do is I'm going to rewrite this in its characteristic equation. So we take a second derivative, call it r squared. The first derivative, call it an r. The function, leave that as a constant. There's my characteristic equation. And what are the solutions to that characteristic equation? Well, if I factor that, I get r minus 4. R minus 4 equals 0. So I get r is 4, but that's a double root. Okay. And in this problem, a is what? Minus 8. So that's just that term. And b is 16. Now, why am I calculating that? Okay, so I've got that calculated. Let me end this show. Let's go back to the notes here. So let's see here. We've got our solutions for the characteristic roots. We've got that R1, R2 right there. We've got A and B. We've got that right here. Okay, so let's look at A squared and let's look at 4B. So what is A squared? A squared is 8 times 8, that's 64. And what is 4B? Well, B is 16. 4 times 16 is 64. So A squared equals 4B. If A squared equals 4B, then the solution is critically damped. So this is this right here. And there's your answer right there. It actually, here, let me use the box. If A squared equals 4B, there's your solution. C1 plus C2x times e to the R1x. So let's just, go through this. So again, A squared is 64. 4B is 64. So therefore, y is, and this just comes straight from the manual, C1 plus C2x times e to the R1x, and R1 was 4. Bam. Really, really easy. Don't let the statistics scare you. It's not intended to be scary. All right. Vectors. Let's look at some vectors. So we got the value of the following cross product. So this is a mixed product in vector land. So we do the cross product and then we dot it with a. So whenever you do a dot product, you get a numerical answer. Hence why all of our choices are numbers. Now you can do this problem a couple different ways. What I'll do is I'll do the cross product first because I kind of want to review cross products and dot products. So B crossed with C. So what do? I set up a 3 by 3, put my I, my J, my K. The B terms here, 1, 2, 3. The C terms, 3, 4, 5. Now, I'm actually going to do this a little differently than I've done in previous reviews. A lot of times what I'll do is the Saris rule, and I'll put the, those columns there and do the products, that way, and then the products that way and take the difference. I'm going to do cofactor expansion. I think sometimes it's a little easier, and sometimes it's nice to just have a different way of doing this. So how do you do this dot product using cofactor expansion? You take I times a determinant minus J times a determinant plus K times a determinant. And what are those determinants? Well, what you do is, let me use a different color. Let's say we're doing the I determinant. Well, what you do is you cross out the row and the column associated with I, and you get 2, 3, 4, 5. For J, cross out the row and the column associated with J. I can do a little better than that. And what numbers am I left with? 1, 3, 3, 5. You can see those numbers left over in the big matrix. What about the K? Cross out the row, cross out the column. 1, 2, 3, 4. Pretty slick. And then what do I get here? I get 2 times 3, or sorry, 2 times 5 is 10, minus 3 times 4 is 12, minus 2i. What about the j? 1 times 5, 3 times 3, so that's negative 4, but I'm subtracting that, so that's plus 4j, plus 1 times 4 is 4, 2 times 3 is 6, minus, I guess I got ahead of myself, plus a negative, I guess that's just minus 2k. And if you're having a hard time following what I just did there, it's just if you have a determinant of a 2 by 2, you just do those two minus those two. That should be pretty easy. Now that's B cross C. If I'm going to do A dotted with B cross C, here's my B cross C. That's my A. I need to bold that. I forgot to bold that. I do, each of the numbers, each of the I coefficients, the J coefficients, the K coefficients, just multiply those together and add. So 6 minus 2 plus 4, sorry, I guess I should keep my direction, 8, 4 plus 10 minus 2. So 6 times 2 is minus 12, 8 times 4 is 32, 10 times 2 is negative 20. That actually comes out to 0. So, again, not hard, just a quick overview of some dot and cross products. What is the angle between two vectors? There's a couple of ways to go about this. You can use either cross products or dot products. I find that dot products are a lot easier. The definition of the dot product states that if you have the magnitude of A times the magnitude of B times the cosine of the angle between them, that is actually the dot product. Like that's how we define it. That the magnitude of A times the magnitude of B times the cosine of that angle, that is the dot product. So I can do this, sort of step by step. What is the dot product? It is 4 times 24 plus 12, minus 8. All right, so when you plug and chug that, you'll get 36. The magnitude of the a vector is, we break out the Pythagorean theorem and we say 4 squared plus 12 squared, 6 squared. And when you plug and chug that, 4 squared, 12 squared, plus 6 squared, and then take the square root of all that, you get 14. And then for your b vector, that ends up being 26. And so if I go back to this expression, so 14 times 26 times the cosine of an angle is 36. So theta is going to be the inverse cosine of 36 over 14 times 26. And so when you chug that out, you end up getting like 84.32 degrees. So that's B. I'm sure this is probably again a lot faster than what we do in class. But again, that's the beauty of YouTube. You can always just sort of pause and pause and review. Okay. Last topic is the wonderful world of statistics. I have 3 problems here, I believe. I think it's 3 related to statistics. It might be more. Let me check. Oh, yeah, 4. Sorry, it's 4. Because I have one probability or one normal distribution problem because I think that's kind of relevant. What is most nearly the sample standard deviation of the following data set? The first point I will make about this problem is that your calculator can do these problems for you. I'm going to do the method, the pencil to paper method with you, but you can plug these values in and just click, give me the standard deviation and it'll do it. In the interest of time, I'm going to just go through the process here, but it's really worthwhile to review that. Okay, now how do you determine the standard deviation? Well, the first thing that you need is the mean, and the mean is the sum of the values divided by the number of observations. So just 4 plus 6 plus 9 plus 9 all over 4, and so that's 7. And so the way that I like to do standard deviations is I draw myself up a little table. So I write down each of my values. Then what I do is I say, okay, give me the distance from the mean. Okay, so what I mean by that is 4 minus 7, 6 minus 7, 9 minus 7, 9 minus 7. So the distance from the mean. Then what I'm going to do is square that. Okay, so 9, 1, 4, and 4. And I'm sure you probably did this when you took statistics. So it's just been a while. Sum those up. You get 18. The reason why I'm doing that is because if you just write the formula for the standard deviation here, let me make those lines smaller. The reason why I do that is because if you write the formula directly from the manual, the formula for the standard sample standard deviation is 1 over n minus 1 times the sum of xi minus x bar squared. And I see that and I go, oh god, that looks horrible, but it really isn't. All you do is take the average, take the distance from the average, square it, add them up. And so you're just going to get 1 over 4 minus 1, which is 3, times this sum, which is just 18. And so I know it seems intimidating, but it's really just the square root of 6. And the square root of 6 is something like 2.4. Looks horrible. Really isn't. Really is pretty straightforward. Okay. What is most nearly the mean of the following data set? Okay, this is whenever you have a problem that involves a weighted average. And so, what we have is, some observations. We have the value 2480 that was observed 23 times, the value 2440 that was observed 35 times. What we're going to do is a weighted average to give you kind of an idea how this works. Let's say we had the values 7, 7, 4, 4, and 4. Okay? The way that we're going to do this is if I wanted to find the mean of this, what I would do is I'd sum these up and I'd divide by 5. But another way of writing that is to say, well, let's take a look at the 7. How many times did we observe it? 2. And then let's take the 4. How many times did we observe it? 3. And so we come up with a formula that's very, very similar. We just take the value times the number of times it was observed and then just sum those products up. So what we can do is I'll be kind of lazy and just do this over to the side. What is V times F for each of these quantities? So V times F. And so all I'm doing for the V times F, that's just like that product right there. The value times the number of times it was observed. And so 2480 times 23, it ends up being like 57040. And then just keep doing that down the rows. 2440 times 35, 85,400. 96,000. 77,880. And 48,720. And so I need some sums. What do I need? I need the sum of this column I just wrote, which it's kind of big, but it's 365, 040. And then which one am I going to use? Am I going to use this column or am I going to use this column? And the answer is I'm going to use this column because, look at the analogy, up here. This is the product. And then down here, that's the frequency, the number of times that those elements showed up. So this sum here is 152. So therefore, X bar is 365 over 152. 365,040 over 152. And when you plug and chug, you get 2401.6. So it looks complicated, but it really isn't. It's just a weighted average. Pretty straightforward. 2 more problems. I'm just curious. How are we doing? Oh wow, we're doing pretty good. 2 problems. Okay, linear regression. Again, this is another one of those problems that your calculator could do for you. And whenever you're doing linear regression, it's not very, very hard. It just ends up being a lot of grunt work. So linear regression is used to whenever you have a series of points, I've got a bunch of points here, and I want to find the best fit line through those points. In order to do that, I end up needing like a lot of repetitive quantities. And so, again, it's one of those things that your calculator can do for you. So let me show you what I mean. We're going to need the number of points, that's obvious. That's 4. Let's look at the sums that we're going to need. So for the sum, we're going to need the sum of the x terms. So that's 1 plus 2 plus 3 plus 3, 11. We're going to, here, let me get rid of these parentheses because that's going to get kind of nuts. So that's 4, sum of the x, which is 11. We're going to need to square that, 121. And then we're also going to need the sum of the x squares. And so the difference between these two is the sum of x, the quantity squared is just squaring the 11. This is 1 squared plus 2 squared plus 3 squared plus 5 squared. And that's not the same thing as just taking 11 and squaring it. And so when you do that, you get 39. We're also going to need the same thing with the y's. So the sum of the y terms, 6 plus 7 plus 11 plus 13 is 39. We're going to need the sum squared, which is 1369. And then we're going to need the sum of the y squared, which is 375. And lastly, we're going to need the sum of x times y, which is, 1 times 6 is 6, 2 times 7 is 14, 3 times 11 is 33, 5 times 13 is 65. Adding those up, you get 118. Okay. All right. Why do I need all of those sums? Because those go into the pattern of linear regression. Let me to walk you through that. And again, the secret answer to a lot of this is the manual. Okay, let me end the show. Go back to the manual. Let me go into statistics land a bit. Let me see. Let's go back to the beginning. I don't have my keyboard connected to my Surface, or I would just Control F. Whoop. Okay, we're getting warmer here. We've got statistics. So you can see the standard deviation formula that we used a little bit ago. Linear regression. That's what we're after. Okay. So linear regression, we're using, the model A, y equals a plus bx. And so what are we after in this problem? Let's go back to the problem. The problem is asking for the slope of the line. So really we're looking for this b hat term. Okay. So what is b hat? Sxy over sxx. Okay. So what do we got here? We've got the sum of x times y. So sxy is the sum of xy minus 1 over n times the sum of x over sum of y. So maybe I'll sort of write that with you. So sum of xy minus sum of x, sum of y over n. Right? Let's see. Did I get that right? Yep. And then sxx is sum of x squared. Sorry if I'm flipping back and forth. This one's the one problem I don't have already done. Minus sum of x squared over n. And so what do we got? So this is 118 minus 1/4 of 11 times 39. And then this is 39 minus 1/4 of, let's see, hold on, what did I get wrong? Oh, I see what that's that. 121. So let me break out my trusty calculator here. So this is 43 over 4, 10.75. This is 8.75. And then what do we got to do? We've got to take SXY over SSX to get the slope of that line. And we get, let's see. I'm getting this one right here because I'm getting like 1 point. I'm actually getting 1.23. I'm gonna have to check the check this problem out because this is the one problem I didn't have already done, and maybe it's just late and I'm lack of sleep, but I'm not quite getting the answer here. I'm getting close to 1.33, but I'll have to check that one. Maybe I'll post something to Teams on that one. This one is our last one though. In this one, we are going to need the manual because we have to use the normal distribution. This one, we have the final scores on a test that are normally distributed with a mean of 72 and a standard deviation of 100 or of 10. And so we need the probability that a student's score will be between 70 or 65 and 78. So we're going to need z-scores. Which has probably been a while since you looked at that, but we just take x minus the mean and divide that whole thing by the standard deviation. So we need, we need the z-score for 65. Which is, negative 0.7. And then we need the z-score for 78. Subscript 78. Positive 0.6. Okay. So let me go back to the manual. Okay, so here's our unit normal distribution. On the problem, what we're trying to do is we're trying to find the probability that the score will be between 65 and 78. So what we're trying to find is if here's the bell curve, this is 65 or a z-score of 0.7, and this is 0.6. We're trying to find that total area right there. What I propose that we do is we look at the what the manual gives us in terms of areas, and it gives us this function here and this function here. And so what I propose is we use the f of x for the 0.7, and then we use the r of x for the 0.6, and if we take the difference of those, that'll give us the area. See, what we're doing here is we're saying, if I have, let's say this is right here, this is 0.7. If I determine that area, that's f of 0.7 according to the manual, the notation the manual is using, which is this capital F, right there. And right here, that gives us a distribution or an area under that normal or that bell curve of 0.7580. Well, for the 0.6, what I really want to do is let's say this is the 0.6 or the negative 0.6. Really what I want to do is I want to take that tail area and subtract it from that. And if I can subtract it from that, that'll give me the total area under the curve. And that's going to be r of 0.6, which is, let's see, 0.242. So if I take the difference of those, which is really what I'm trying to do, if I take, you know, this bigger area minus this smaller area, that gets what I'm after up here. And so the difference of those, let's see, if I subtract that, I get, wait. Oh, I did that backwards. I'm sorry, I did that backwards. I'm so sorry. I think my caffeine for the day is wearing off. This should be the 0.6, and this should be the 0.7. I did that backwards. Let me go back and look up these values here. Okay, so for the, this should be, this should be 0.6. This should be 0.7. Sorry about that. Really, I should be using this value here and that value. That's what I was doing wrong. I knew I had something wrong here. 0.7257, and this one is the 0.242. So now if I take the difference of those, I get 0.4837. There we go. That's a little better. Okay. Before I call it, I want to pause my recording real quick. I want to take a look at this problem 20 real quick and make sure that I clarify what and see if there's any issues with my calcs here. So give me 1 sec. Let me look through this. So I see what happened. Simple mistake. I had here written that this was 39. That's wrong. It was supposed to be 37. So what happened was when this was 37, it made this 16.25. And so the slope is 16.25 divided by 8.75, which is 1.86. So it was just a minor calculation error. I had that written as 39, but it was 37. Ultimately, what you're doing is you're taking the SXY over the SSX and, you know, just plugging your values in and chugging it out. Isn't really too bad. And again, I know I went through a lot of problems very quickly. Our videos, you know, just over an hour long, but this is a pretty in-depth review of pretty much all the math that you could expect on the exam. It's a lot of concepts, but the problems, again, while there are a lot of problems, each problem by itself isn't really that hard. Just take your time, and you'll do just fine. That's all I have. We'll see you all next Wednesday.